Another topic from A level and even GCSE are of course the flame tests, very familiar for predominantly the alkali metals and the alkaline earth metals. So if you think of the alkali metals, these are described usually as crimson red for lithium, orange for sodium, lilac for potassium. It's a deep red purpley. I couldn't find a good deep red one for rubidium. I think I'm going to have to go and grab some rubidium and do my own flame test of it. And then sort of sometimes described as sky blue or closer to purple for cesium. Potassium and cesium sometimes harder to distinguish between, but of course, quite frankly, if you don't know whether you got potassium or cesium salts, you probably don't know much. Alkali metals, calcium, brick red, strontium, usually described as crimson, and then barium, a green, sort of sometimes yellowy green, more often apple green. One that's always left out of the flame tests is magnesium, because magnesium ions are colorless, but magnesium metal, really awesome when you set fire to it. So that's what you see when you set fire to magnesium ribbon. We'll do that at some point. Certainly it's a good demonstration to do for a variety of school classes and so on. Another main group element to bring out in terms of having pretty colors, flame tests at any rate, is boron. Gives you this gorgeous deeper green there. So you get greens from barium and boron. Quite frankly, I prefer the boron one. And the colors associated with main group elements associated with noble gases. So neon lights have this nice red color. Remember, it's neon is a very distinctive red. But the other noble gases have got very distinctive colors there. So helium is sort of peachy, argon, obviously that blue, krypton is silver, and then xenon, that sort of bluey purple. I should, of course, as you know, give a citation for where I got these beautiful pictures from, but it's one of those interesting things about the internet. If you put up colors of noble gases or do some kind of search on Google Images, you find these 5 beautiful little lights identically at about 50 different websites. So I haven't actually cited any of them because I don't know what the original website was. And I'm blowed if I'm going to cite somebody who nicked them. Anyway, while we're on the subject of cute colors associated with main group elements, I'll throw a few more at you. The halogens, of course, you've got fluorine, chlorine, bromine, and iodine. Fluorine is sort of a greeny, closer to green than yellow, chlorine closer to yellow than green, bromine very distinctive sort of orangey brown color, and then iodine, this is iodine vapor, that nice purple you see. Of course you might be more familiar with it in terms of the brownish that comes from the solid dissolving the solid up. So I think so this purple is actually nice, and when you look at the solid really closely, you can see it looks more purpley than brown. Guess what element that is? And the answer is oxygen. Liquid oxygen is a lovely blue color. It's also very explosive, so be careful with it. And while we're in there, of course, sulfur is that nice familiar yellow. Phosphorus has 3 common allotropes that are detailed in the allotrope movie. The most common form of phosphorus is white phosphorus. That's a waxy white solid that you have to keep underwater. So any picture of that is just a waxy lump underwater. This is red phosphorus that has uses in matches and so on. And there's also black phosphorus, but that's boring. The other main group elements are colors associated with sort of boron. They're sort of metallic-y, so I'm not going to put those up there. But anyway, some pretty little colors associated with main groups. Flame tests, the emission spectra associated with the noble gases, and then some colors of the other non-metals.